I'm measuring the voltage of the power source right now. You see you have the voltage wire connected to the hot probe and then the ground wire connected to the black probe. It's varying between 4.78, mostly 4.78 and 4.8. So we're going to say the voltage is 4.9, kind of the middle value. This is the resistance of the 220 ohm resistor. It's holding steady at 255 ohms. As you can see here, I'm measuring the resistance across the 1000 ohm resistor. It's holding a steady 1014 resistance, 1014 ohms. So that's the resistance. So this is the circuit of two resistors in parallel. You have the power supply, which we measured to be 4.89. Resistance 1, resistance 2, which we measured to be 1014 ohms and 255 ohms. Then we want to find current 1, and then current 2, which is going into R1, and then current 3, which is going into R2, and then current 4, right? We can find the voltage drop across each resistor by using Kirchhoff's loop rule, and it's just going to be 4.89 because none of them are in series, so voltage is going to be the same throughout. So each resistor has a 4.89 voltage drop, and we can use that, the resistance plus the voltage drop, to find the current. So we have the expected voltage drop, we have the measured resistance, and now we can find the expected current. And so the expected current across resistor 1, I2, is going to be 4.822 milliamps. And then I3 across resistor 2, right, is going to be 19.176 milliamps. And then you know that I1, because of junction rule, I1 is going to equal I3 plus I2. I4 is going to equal I3 plus I2. So I1 equals I4. And then the equivalent resistance, which is the inverse of which is adding the inverse of each resistor and then taking the inverse of the sum, is going to be 203.7588 ohms. And this lines up because we use the equivalent resistance and the power supply to find I1 and I4 to get 23.999 milliamps, which lines up with the multisim.
Okay, so this is the circuit, right? Parallel resistors, you have resistance 1, and then I used a reference voltage and this voltage combined to get the voltage drop across the resistor. As I said before, the calculated voltage drop across each resistor is the same as the voltage source, 4.89. The current flowing into, and i.e. out of as well, resistance 1 is the same as the calculated value, 4.8225 milliamps. And for resistor 2, it's also the same as the calculated value, 19.176 milliamps. Now, current 1, the current flowing into the parallel circuit, is the same as the calculated value, 23.999 milliamps. And again, I1 equals I4, except on here it's displaying a negative value because it's reading current in the opposite direction. So my calculations line up with the calculations in multisim.
This is the circuit. You see we have the power wire, and then there's a wire connecting the power. There's a separate wire connecting the power wire to the actual parallel resistors. This is so we could unplug this white wire and measure the current from the green to the white, which is getting us the current to the parallel resistors, not in between them. Then we also have the same thing, but going from the parallel resistors to the ground. It's the same setup for the same reason. And then the way we're going to measure the current to each individual resistor is we can't unplug this because it would break the connection. So we put this blue wire in the parallel thing, then unplug one of the resistors, then measure from the blue wire to the resistor. And we'll do that for each resistor. That's how we get the current in each resistor. So let's start off by measuring the current in each resistor and comparing it to the expected current. So we're measuring the current from the power to the parallel circuit, I1. The expected value is going to be 23.999 milliamps. The actual value being measured is it's fluctuating. We're going to say it's 25.8 milliamps. It's a little higher than the expected value. And obviously, the current going from the parallel resistors to the ground should be the same, and we're about to check that. As you can see, we're measuring the current from the parallel resistors to the ground, and the current is not the same. It's about almost a whole number off, give or take 0.1. I'm not entirely sure why that's the case. Maybe the current's maybe there's a contact resistance in the breadboard that's messing up with the currents. Not too sure why this is the case. But maybe I set up my circuit wrong. You can tell me if I set it up wrong. See, we have a wire going from power, and then we actually have two wires that are dedicated to power. That way we can measure between the junctions. And then they go to these resistors that are in the same line, so they should be in parallel. Then a wire going from their ending parallel point all the way to ground. Here I am measuring the current across resistor 1, which is the 1000 ohm resistor, or the actual resistance is 1014 ohms. And the expected current was 4.822 milliamps. It's 4.8 milliamps, so it's at least close. I can't see whether it's 4.822 or 4.821, but it's at least 4.8 milliamps, so it's accurate to the tenths place. So yep, across resistor 1, and then I'm going to measure the voltage drop across it now. Here we're measuring the voltage drop across resistor 1, as you can see. And the voltage drop is 4.69, which is a little less than the expected voltage drop. Again, maybe there's contact resistance in the breadboard that's causing this. Here we're measuring the current. See, the blue wire is going from the parallel to the actual resistor. So we're measuring the current across resistor 2. The expected current was 19.176 milliamps according to my calculations and multisim. The actual current is 19.6 milliamps, which isn't incredibly far off, but it's a lot further than I was hoping it'd be. Across the first resistor, it was pretty good, pretty close, maybe even exact. The second resistor, it's a little further. And we also saw this when the current to the ground was less than the current from the voltage source, which, even though they should have been the same. This is the voltage drop across resistor 2. It's currently fluctuating quite a bit. We're expecting 4.89, but it's been fluctuating quite a bit. Earlier, it was all the way up to 4.96. I don't know why it's fluctuating so much, but right now it seems to be on the lower end. At one point, it was sitting at exactly 4.88 consistently, but now it's fluctuating again on the lower end.